You're most welcome once again to this YouTube channel. So today we're going to talk about partial fractions, and without wasting any minute, what we call a fraction, it is in this form. Always a fraction should have a numerator and a denominator. Now in this case, the fraction of ours, the numerator is an expression, the denominator is also an expression, both in terms of a given variable. The variable here is x. So the question is express this fraction into partial fractions. So our task is to turn this into different fractions. It is a single fraction which we want to break down into different fractions whose sum is equivalent to this fraction. So our focus shall be always on the denominator. And now, like for example, in this case, if the denominator is factorizable, this is x squared. If the denominator is factorizable, for example, x squared plus 5x plus 6 can be factorized, and this is x plus 2 into x plus 3. You can factorize this, or you can visit the previous lessons in the previous videos. So if the denominator is factorizable, we shall always factorize it, and we shall get our linear factors. These two factors are our point of interest. So this will turn into x plus 4 all over x plus 2 into x plus 3. So we shall let the whole of this fraction, which is now this one, to be equal to the different parts which we are to find. So for each denominator, for each factor, in our denominator, for each factor, we shall let something up there. If this is a linear factor, we shall let a constant plus, this is also a linear factor, x plus 3, we shall let another constant. So our answer is this, because these are the partial fractions whose unknowns a and b we should look for, and we conclude again that this is our answer. These are the partial fractions. These are the two fractions whose sum should be able to give us this. Now the remaining part is to solve, to do the normal algebra. So our LCM here is x plus 2 into x plus 3. So this shall be a into x plus 3 plus b into x plus 2. This is therefore equal to this as well. I can rewrite it here. In this case, let me write it. We can save our time and leave it. So as you see here, since the denominators are the same, it implies that this term to be equal to this, the numerators should also be equal. So I will say x plus 4 is equal to a into x plus 3 plus b into x plus 2. And from this stage, this is our stage of interest, we shall let different x values for which we shall be able to find a and b. Remember, our major task is to look for a and b. So in this case, I can let x to be 0, to be a 1, to be a 2, to be anything, but I will be intentional to let an x value which will make things reduce. For example, I will let x to be equal to negative 2, because if x is a negative 2, this will become a 0. Negative 2 plus a 2 will become a 0. So I will substitute this new x, this x of mine, in this expression. Negative 2, the left side will become this, equal to a into, where I'm having x, I'll put a negative 2 plus a 3 plus this also, but I'm saving my time because negative 2 will make this a 0. That's why I was intentional on this. Now, what if the denominator is in this form? What shall we do? We shall see whether we can factorize everything here, appearing not to be a linear term or a linear factor. So this quadratic factor here, can it be factorized? Yes, it can be factorized. Whenever it is factorizable, you factorize it. So our x squared minus 9 is the same as x plus 3 into x minus 3. It is the difference of two squares. So this shall become 4x minus 1 over x plus 2 into x plus 3 into x minus 3. So we shall let this to be equal to, for each linear factor, we shall insert the constant. And this 1x plus 3, shall put the constant, plus finally x minus 3. So this is the form in which our answer should be, and the task is to look for A, B, and C. So we shall proceed as we have done in our first example. We shall find the LCM here, which is x plus 2, x plus 3, x minus 3. So in our numerator we shall get a into x plus 3 into x minus 3 plus b into x plus 2 into x minus 3, then plus sc into this and this into x plus 2, x plus 3. You must look at it that when this denominator is to divide each of these 3, we must get back this. So after doing this, we can rewrite this again here, but to save our time we shall just say 4x minus 1, because this is equal to this, so this is equal to this. Denominators are the same, implying that numerators should be equal for this to be equal to this. So 4x minus 1 is equal to a into x plus 3 into x minus 3 plus b into x plus 2, x minus 3 plus c into x plus 2 into x plus 3. So from here you will let, from this stage you will let x to be a certain number, and you will be able to get all these constants. You will a, b and c, will be able to find them. So for instance, I can be intentional to let x to be a 3, which will make this a 0. This will be made a 0. A 3 will also make this bracket a 0. So I remain with only that. So x being a 3, I have to substitute it there. Minus 1 is equal to, this is a 0 and this is equal to a c into our x is a 3 plus a 2, 3 plus a 3. So you realize this equation is having c as the only unknown. So you get a c. You let another value of x, you get another unknown. You let another value of x, you get another unknown. After you conclude that this is our answer. So that is it. Now what if our fraction is in this form and the denominator, it is having two factors, of which one is a quadratic one. If this was factorizable into two linear factors, we would proceed as we have seen in the first examples. But now this quadratic factor, this quadratic expression is not factorizable. That means there is nothing to do about it. So we have to just let all this x plus 2 into x squared plus 2x. We shall have to let all this to be equal to, for this linear expression or factor, we have already said we shall let there be a constant. And for this quadratic expression, which cannot be factorized, we shall let a linear expression up there. That is bx plus c. You can refer from the equation of a line being in that form, where m and c are constants. Of course, m is a gradient, but it is a constant for a given line. It doesn't change. C, it is also constant, an intercept. So m and c are given numbers which do not change, which are constants. So I can, this is just change in language, calling m a b or c a c, and so whatever I have called it this way. Suppose I had the two linear factors here and another quadratic one here. So I could have let a linear one for this. Now if this was an x minus, I could let a constant for that. maybe if this was an x plus 5, x plus 5, a b, then plus something like that. Just following letters in their order, and this, if it is a quadratic expression which can't be factorized, for it I would let linear expression in that form. So after letting that, these are the two parts and they are fractions. So I will find the LCM, which is x plus 2, x squared plus 2x plus 7. This will be a into x squared plus 2x plus 7 plus bx plus c, all these into x plus 2. So I can write this again, but to save my time, seeing that the denominators are the same, it implies that the numerators are the same for this to be equal to this. So this is equal to a into x squared plus 2x plus 7 plus b c b of x into that. So reaching this stage again, it is where we let different x values. So I can let x to be a negative 2, let x be a negative 2. This will be, so you substitute wherever you're seeing an x, you substitute the negative 2. So this will be 4 into negative 2 minus 4 into, I want to write this because it is turning into a 0, which is as good as nothing. So this is a into negative 2 squared plus 2 into negative 2 plus 7. So this is negative 8 minus 4. Negative 8 minus 4 is equal to a into, this is negative 2 squared, that is a 4, plus this is a negative 4, 2 into negative 2 is a negative 4, then plus a 7, implying that this is negative 12 into a into, this is a 0, so we remain with a 7, implying that our a is a negative 7 over, divide both sides by 7, so our a is negative 12 over 7. So you continue, you let another x value, you can even let x to be, let us just see one more hint on this. It is from here where we are letting from. So we can let x to be a 0. So this turns out to become 4 into a 0 minus a 4 equal to a into, you substitute, don't play with the substitution, plus 7 plus c. Now we are here, this will become b into a 0 plus c, still into a 0 plus a 2. So you simplify, this will become negative 4 equal to a. We already know a. You substitute it there into a 7 plus c. This is a 0. So in this bracket we remain with a c. In this bracket we remain with a 2. So you realize the unknown in this statement is a c. So you find a c. Then you continue. After getting your c, let us try getting it. This will cancel, negative 12 plus 2c. This coming this side, it turns out to become 8 plus 2c. So our c is a 4. This comes this side, becomes a positive 12, which reduces with this to this. So you let Are you seeing? We are having our A and our C. So you let one more unknown. No, sorry, you let one more value of x. Let us say 1. So letting x to be 1, it means that we shall substitute here by a 1, and here by a 1, here by a 1. We already have a, we substitute it there. Here by a 1, so we don't have b. We have c, you substitute it c there, you substitute here our 1. So the statement shall have b as the only unknown. So you will find b as well, and you will conclude. You will conclude very well your answer in this form by substituting there a, b, and c. Okay, ladies and gentlemen, let us try out these questions on our own. And for this last question, it is about a concept which will come in our next video. So be waiting for the next video in a few days. Thank you for watching this video. Let us stop it here, for it not to be very long. I remain Wami Lisa, your math guy. Thank you for watching. Don't forget to subscribe.